We'll continue with a speaker that will teach you about interface between your app and the server. And I ask you to welcome Jeffrey Macko.
Hi everyone, I'm Jeffrey Macko. I've been doing iOS development since iOS 3. Currently I'm working at Pajon and here in Paris. The goal of this talk is to share with you how we automate our API client library. It's an experiment we did the last few weeks. And since most iOS developers have a network backend, we thought that it could help if we share. First of all, what is automation? Wikipedia say it way better than me, so let's repeat it. Automation is just a technology by which a process or procedure is performed without human assistance. Okay. Why did we do this? Our web services are pretty large. We have a lot of endpoints, a lot of models, and it's changed a lot recently. And it's fun to try new technology and share them with you. When we will most certainly never have to use F-networking and Alamofire again, because the goal of all of this is to automate our network stack, so we'll not have to use it, because with Callable, JSON decoder, and URL session, there is much less need for network library. Our main goals are to be always up to date with the backend web services. Since it's changed a lot of time and really fast, we always have to update everything in order to work with it. Reduce work on repetitive tasks with loaded value. Adding a property to a model, it's boring. I did a request, it's boring. Do it over and over and over again, it's really boring. Simplifying our code base and improve consistency. Using code generation, our code will work the same way and will look the same and will be way easier to maintain. And having adapted documentation baked directly into our library is a great bonus. So, this is basically how our client library worked before. Imagine, you just have to add like an air color to a user model. Our backend team have to implement it, create and update the documentation, update the API tester. We, the iOS team, we have to implement a new feature into the library, test it, tag it, deliver it, create everything around the pod, update the main project dependencies with the new library that we've just created, and make a PR with the new library. It's a lot of steps. It's way too many steps. Doing this way consumes a lot of energy and a lot of time. And in a way to optimize our workflow, we choose to automate like everything. And it will help us reduce the possibility of error in implementation. So, what do we have now? Our backend team continues its work, implementing the API and implementing the API documentation file. And we have a new step in between, that is the automation process, that creates some of stuff that the backend team was doing before, like updating the documentation and the API tester. But it does a lot of other stuff that we was doing before, like implementing the new feature into the library, test it, tag it, deliver it, etc., etc. How did we do it? We start by finding a good API description file and generate it. We define how we want our code generated through template file, how we want our API, how we want our request handled. And we use this API description file to generate the client library. What is an API description file? It's really easy, just a file that describes our REST API functions. Like Swagger, like OpenAPI, like RAML, like API blueprints, there is a lot of API description file format. An API description file is really a contract between the server and the client. It will help to share design process, generate API documentation, validation, testing, client code, server code, mock server, mock clients. I mean, we can do everything with it. We choose Swagger at Passion because it seems more mature. It's really easy to learn and to use. It's using JSON schema in order to define how it works. It's open source. It's evolved into OpenAPI, and now OpenAPI is backed by a lot of companies. It's really easy to understand, and there is really a lot of tooling around it. So one tool we use for this is called SwagGen. I will talk about it more later. So, the automation script. This is everything we have to do before, like really well detailed, and there is a lot of steps. But today we will only focus on one step, how to generate the library. And for that, we use a tool called SwagGen. So, how SwagGen works? It's pretty easy to use, actually. You just have to customize your model and your API clients through topology and options. Like you say, I want my model to work this way, I want my API client to work this way. It's just a Swift file, and you add stencils in it in order to make it work. It generates all the model, it generates the API client layer, and it's pretty work. Yeah. I will show you an example, a small example, easy example of how Swagger file is defined. As you can see here, it's YAML, but it can be JSON. This is the part of the file where it's defined a path for a request. This request is a pet. It's the post request. We can see summary and a few information around it. We can see the request, it's a post, it's have a parameter called body, and it takes in something called a reference definition pets. It's really interesting because the reference is just a reference to another place into the YAML file. And this place is in definition, and the object is called pet. And it responds to 4 or 5 definition, evaluated input if it's failed. Let's see what a definition looks like. A definition is an object, as you can see. We can see the required property of it. There is a few property, ID, category, name, status, etc., etc. And IDs, you can have the type of everything, ID type integer, in 64, sorry. Category is a reference to another model. Name is a string with an example. And status is a enum, a string here. So, as you can see with this, you can really understand how your web services works. So, automated generation. This is just the output that have been generated when you launch it. As you can see, it's pretty easy. SwagGen generates. You pass it the file, and it do its stuff. It only takes 6.42 seconds. It's really, really fast. And it generates the API client library. I mean, 330 models, the API client layer for approximately 44 endpoints. And it can work on Android or any other languages because it's just code generation. It can work for everything. Now, we try small experiments with human generation, with developers. Working on a repetitive task with loaded value, like editing models, creating requests, etc., etc. It takes only a few seconds. I'm not gonna tell this. And as you can see, the human can do basically the same thing, but with a few bonuses, like some bugs, less rigorous code, and less feature in the project. The automation script that you see before take 3 minutes for doing everything. Thank you.
Thank you. Please. I don't know if a lot of people are using that kind of approach today because there are other ideas to go in a bit in this direction. Maybe we can have a quick poll in the room. Who's using something that looks like that, like not writing your network code yourself, but having it generated? Okay.
A few people.
Yeah.
Yes.
And who's using something like JSON API or protobuf or stuff like that? Yeah.
GraphQL, anyone? Okay.
Interesting.
Nice.
And who's still writing everything by hand, like controlling? Yeah, actually, it's another point of view. You have a more fine control, I think. Thank you. And I think your code base was really huge at Pajon.
Yes.
So did you show some number at the end? But do you have an idea of like how much code did you really track the code that you've been able to remove? Did you do some measurements on that? Or?
I don't have the measurements exactly, but it's a huge code base. We remove all the network stack was in Objective-C because it was a long time ago we did it, and we remove a lot of Objective-C when we did it. But I don't have the measurements right now.
Okay, and it's also another good idea to actually remove Objective-C. Yeah, no, it's true. But, and about the code that is generated, how ugly is it?
It's beautiful because I designed the code that is generated through Toplantic.
Don't lie, we're gonna check that. Okay, and about the tool, is it like? Do you think it's gonna be kept in the future? Is it maintained? Is it?
Yes, the maintainer is called Jonas Klomb, I think, and I talked to him a few times on the GitHub. He responds every time. I ask him how to do this or that. He explained me how to modify the project in order to achieve it. He's really reactive, and the project is really active.
Okay, and like a lot of people working on that, or is he alone?
I think he is alone, but there is not a lot of code in this project.
Yeah, by the way, it's just like taking the backend part and of the Swagger gen.
Yes,
right?
it only take the Swagger, the JSON file, it parse it, and then use the OpenAPI representation in order to fill all the templates.
Okay.
Just reading templates and parsing the file and
that's something that could be maintained by another developer. Okay.
And how do you integrate that into your workflow? Like you have it's a build machine who does that for you? Or you just there is one developer who does that, and everybody stops working on the feature?
Today, how it works, when the backend team generates a new version, publish a new version, they call the curl script that starts bitrise and do everything. So we don't have to touch it. It's just at the end when the script's finish, it's create a PR on our main project that said, this is a new library. Do you want to merge it with a diff and a changelog? And we can see if there is breaking change, and if there is, we can take the branch, modify it, repush it, or just merge it because.
Yeah, automation, all there. Okay.
Automation, everything.
Okay, nice.
Very nice.
Thank you. Thank you for your talk.
Thank you.